Okay, so for number 25, it says that this piecewise function is continuous at x equals 1. So guys, remember, for something to be continuous, it has to be defined. So defined means that it just has to be equal to it. And then it also has to mean that the limit from the left and the right have to be equal to each other. So like graphically, if you have a line and let's say it has a hole in it, there would actually not be a hole. This would have to be the actual point. So in this case, that point's going to be at A. And then if you come in from the left and you come in from the right, you should all end up at the same point here. Okay, so that's what that means graphically. So what we're going to do is, first off, this part that's defined tells us that at the point 1, that y value has to be A. So whatever we get for the limit part, we're going to have to set that equal to A. That's going to be our answer. So this is the actual point. This is the equation of the graph if you come in from the left and the right. So we're going to need to find the limit as x approaches 1 of the square root of 3x minus 1 minus the square root of 2x over x minus 1. So if you remember, for limits, the easiest way to do it is to do direct substitution. So we're going to plug in 1. So if you plug in 1 there, you're going to end up with 0 over 0, which is called the indeterminate form. So remember, we learned L'Hopital's rule later in the year. This says if you end up with the indeterminate form, you can find the derivative of the numerator and the denominator, and then you can do direct substitution. Okay, so to find the derivative of the numerator here, I'm going to rewrite this as 3x minus 1 to the 1/2 power, and then we can use the chain rule. So it's going to be 1/2 times 3x minus 1 to the negative 1/2 times the derivative of the inside, which is 3. Then minus, I'm going to rewrite the square root of 2x as 2x to the 1/2. I'm going to use the chain rule again. So this will be 1/2 times 2x to the negative 1/2 times the derivative of the inside, which is 2. Alright, then you're going to find the derivative of the denominator by itself, and that is just going to be 1. So at this point, you would just do direct substitution. I'm going to go ahead and simplify this limit before we actually plug in. That way it'll be a little bit easier. So here, this would give us a fraction with 3 on top, 2 on the bottom from the 1/2, and then the square root of 3x minus 1. Then we have subtraction. Here, the 1/2 and the 2 would multiply and cancel, and we would just have 1 over the square root of 2x. Okay, it was just 1 in the denominator, so that can go away. So if we go ahead and do direct substitution, so plug in that 1 for x. Then we're going to end up with 3 over 2 square root of 2 minus 1 over the square root of 2. So I'm going to make them have the same denominators. So I'm multiplying this one by 2. So now we can just subtract the numerator. So we're going to end up with 1 over 2 square root of 2. Okay, so that is the answer for the limit part. So if you come from the left and from the right for the limit, you will get 1 over 2 square root of 2. Because it's set up continuous, that means that the point where it's defined, which we said was A at the top, also has to be equal to that. Now, because this is multiple choice, that wasn't an actual answer. So what they did here to get the answer is they rationalized. So they multiplied the numerator and denominator by the square root of 2. So you should get square root of 2 over 2 times 2, so the square root of 2 over 4, which was answer choice B.